Ever wondered how the universe we live in today formed? Or maybe you pondered about how long it took the universe to come into existence? Well, all these questions will be clarified today. Almost 14 billion years ago, the universe we inhabit burst into existence in an extraordinary event that later took on the name Big Bang. In the first fleeting fraction of a second, as we can see in the diagram, the universe expanded exponentially, stretching far beyond the view of our best telescopes. All this, of course, is just a theory that started with one discovery. In 1929, Edwin Hubble realized that the universe is in fact expanding at an enormous speed by using something called the Doppler effect. In a whole, the Doppler effect is an increase or decrease in the frequency of sound, light, or other waves as the source and observer moves towards or away from each other. Hubble found that the light from distant galaxies was shifted towards the red end of the spectrum. This red shift indicates that stars are moving away from us and away from each other, each at a speed proportional to their distance from us. He then hypothesized that there must have been an instance in time where the entire universe was contained in a single point of space. Now, you might not understand this, so I'll break it down for you. A simple process can be used. Stars emit light, yes? Well, using a prism, this light can be spread into a spectrum. If we look at the spectrum of sunlight or any other stars, we'll be looking at the color spectrum from red through to violet. If the star is receding, the patterns move to longer, redder wavelengths, as we can see in this diagram. This is called redshift. After its initial appearance, it apparently inflated, expanded, and cooled, going from very, very small and very, very hot to the size and temperature of our current universe. It continues to expand and cool, clustered together with several 100 billion other stars in a galaxy soaring through the cosmos, all of which is inside an expanding universe that began as an infinitesimal singularity, which appeared out of nowhere for reasons unknown. This is the Big Bang Theory. Now a question may pop into your head after all this. Well, how do we know this is all true? Well, that's simple. The word theory is associated with the Big Bang because scientists still haven't 100% confirmed its likelihood. However, there have been several evidences suggesting that the Big Bang Theory is in fact real. First of all, we're reasonably certain that the universe had to have had a beginning. Logically speaking, everything we know today has had a beginning, even if we weren't there to witness it. As you can see in these diagrams, they look pretty familiar. Secondly, as I stated earlier, Edwin Hubble discovered the galaxies appear to be moving away from us, which suggests the ever-expanding universe was once compacted. As we can see in this diagram, and 2 in this diagram relating the stages of the Big Bang to this stage 1. Now, evidence number 3. The Big Bang Theory states that seconds into the expansion of the universe, the singularity of particles were extremely hot, so it should have been possible to find some remnants of this immense heat. In 1965, radio astronomers Arno Penzias and Robert Wilson discovered a 2.725 degree Kelvin cosmic microwave background radiation, CMB for short, which pervades the observable universe. This is thought to be the remnant which scientists were looking for. As we can see in this diagram, this is exactly what they found, and these two are the two scientists. Finally, the abundance of the light elements hydrogen and helium found in the observable universe are thought to support the Big Bang model of origins. There is a window of certainty, however, but it is clear that hydrogen and helium make up 98% of the possible ordinary matter in this universe. This high percentage of helium argues strongly for the Big Bang model, since other models gave very, very small percentages of helium. Basically, the hydrogen-helium abundance helps us model the expansion rate of the early universe. If it had been faster, then there would have been more neutrons and more helium. If it had been slower, more of the free neutrons would have decayed before the deuterium stability point, and there would have been less helium. Now for the next few points I'm going to make, I think we need to establish a definition for inflation. Well, inflation is the act of rapid expansion and is a term that describes the first few seconds after the Big Bang. As you can see in this diagram here, the first few milliseconds. As you can see here, the inflation grew exponentially very fast. While astronomers studied the universe's beginnings, they've also been seeking out proof of its rapid inflation. Theory says that in the first few seconds of the universe was born, our cosmos ballooned faster than the speed of light, which, by the way, does not violate Albert Einstein's speed limit, since he said that the light is the maximum anything can travel within the universe. That did not apply to the inflation of the universe itself. In 2014, astronomers said that they found evidence on the CMB concerning B modes, a sort of polarization generated as the universe got bigger and created gravitational waves. Researchers from BICEP 2 found the first direct evidence for this cosmic inflation. The data also represents the first images of gravitational waves or ripples, as we can see on the screen. In deep connection between quantum mechanics and general relativity. They did this by using an Antarctic telescope called background imaging of cosmic extralit polarization, or BICEP 2 for short. The universe is not only expanding but getting faster as it inflates. This means that by the time soon enough nobody will be able to spot other galaxies from Earth, or any other vantage points within our galaxy. We will see distant galaxies moving away from us, but the speed is increasing with time. Harvard University astronomer Avi Lieb said that this was a huge change in perspective. Just as scientists began agreeing on the slowing of the inflation by the rule mass creates gravity, and gravity creates pull. The pulling of the universe must slow the expansion. Supernova observations showed that the expansion of the universe, rather than slowing down, is accelerating. Something not like matter and not like ordinary energy is pushing the galaxies apart. This stuff has been dubbed dark energy, but to give it a name is not to understand it. This again is evidence that we are nowhere close to solving the mystery of the universe. Any discussion of the Big Bang Theory would be incomplete without asking the question, what about God? This is because cosmology, the study of the origin of the universe, is an area where science and theology meet. Creation was a supernatural event. That is, it took place outside the natural realm. We know that this today because the universe had a beginning. Well, was God the first cause? I'm not going to try to answer this because today many religions have different views. The Big Bang Theory isn't the only theory to explain the probable origins of the universe. It's just the most popular. Well, I would like to show you two possible theories today. While the Big Bang was making its way into public consensus, there were other physicists that did not go for it. Fred Hoyle, Thomas Gold, and H. Bondi, three other prominent scientists, put forth a theory that has come to be known as the steady state theory. Like the Big Bang Theory of Lemaitre, it was based on philosophical premises, not scientific ones, but unlike the Big Bang, it proposed an eternal universe, not one that was created in time. The theory was based on the cosmological principle, which contained aspects first which were put forth by Einstein. Basically, the idea was that the universe is homogeneous, smooth, and looks the same from any place in the universe, isotropic. If the Big Bang occurred, it would look differently to observers at different times. The steady state theory proposed a perfect cosmological principle. In other words, the universe looked the same to all observers in all times and all places. Astronomers found that the universe actually evolves over time. For example, cosmologists discovered different types of stars that are more common during different ages of the universe, thus proving this theory wrong. Well, there is a new alternative on the horizon. It's called plasma cosmology. Here's a basic idea of what it's about. The advocates of plasma cosmology believe that the evolution of the universe in the past must be explained in terms of the processes occurring to the universe today. In other words, events that occur in the depths of space can be explained in terms of phenomena studied in the laboratories on Earth. This approach rules out the concepts of the universe that began without nothing, something in time like the Big Bang. We can't recreate the initial conditions of the Big Bang in laboratories, can we? The closest we can get is in the particles created in accelerators. Plasma cosmology supports the idea that because we see an evolving universe that is constantly changing, this universe has always existed and always evolved. and will continue to exist and evolve for eternity. Well, to sum everything up, different theories have arisen to account for the origins of the universe. Some proved wrong, some not. But among them, the most popular is the Big Bang Theory. This theory states that everything we know started as a singularity and then expanded into the universe we know today through inflation. Edwin Hubble discovered inflation through the use of Doppler effect, outlining a phenomenon known as redshift. Even though the Big Bang Theory is just a theory, many evidence have pointed towards its actuality, such as cosmic microwave background radiation, the redshift, maybe God, and much more. In the end, out of the many theories of the Big Bang Theory, seems like the most probable one, disregarding the aspect's involvement of religion. Thank you for watching, and the references will be posted in my YouTube description box, so if you guys need to check that out, please do so.